So welcome everybody to our programming the Elegoo robot session. So the goal of this one is really to get you started. So we're assuming that you've got there you go. We're assuming that we have the robot built, and if you don't, that's okay. You'll get to that point, and that's kind of where you want to jump in with this video. So after the robot is built, the next question is, okay, what do I do with this thing? And this is what this presentation intends to cover. So let's get started. So what are we going to cover? Um, what you need before you start. So there are some prerequisites, specifically some hardware setup. What you need to program your Elegoo robot in terms of software and tools. And then we're going to cover one specific setup, which I call the setup for any computer. And then I'm going to quickly touch on other setups that you may like. So they've got some advantages, but they're not maybe as flexible or as universal as the first one. Then we'll talk a little bit about, okay, so you followed the instructions in this presentation. What do you do next? And a little bit about more info, so resources you can grab if I don't catch you. All right, so what do we need? We need the pretty little robot, and it needs to be assembled. If you don't have it assembled, you can, I guess, program it, but it'll be more useful to you if you first assemble it, because then you'll be able to test all the hardware. Do make sure that your robot is charged before you start playing with this stuff, because if it's not charged, you won't get anywhere either. And it's probably bad for the battery to really run it down to the ground too often. If you have a brand new Elegoo, so you've assembled it right out of the box, it's actually programmed with some code that Elegoo wrote. It's not going to be good for you for the game, but it is useful to test the hardware. So you've assembled it, yeah, 100% sure you got everything right. Turn it on, pull out the little IR remote from the box, and pull the little plastic tab out of the remote, because the remote over here, there's a little plastic tab at the bottom where the battery is. That just prevents your battery from dying during shipping. Yank that thing off, and your remote will be actually useful for the robot. So you've got essentially the crosses, forward, backwards, and left, right work. They're not great, but they work. And then I think one puts it into either line following mode or obstacle mode. 1 and 2 should put it into line following mode or obstacle mode. So that should test your ultrasonic sensor and your DC motors. I'm not sure it actually does anything with the servo motor on the ultrasonic server, ultrasonic sensor, but it'll give you a good idea that things are working pretty decently. Once you write code to it, that will be lost unless you go find it again in Elegoo stuff. So it's a good idea to do that first. So the second thing you'll need is the little ESP01 Wi-Fi board. So that came in with your kit of parts. It's not very big. It looks big on that screen, but it's actually pretty small. Let me actually just grab it. Hold on. It's actually already on in a case for mine. I don't know if you can see it. The lighting is not great in here, but this guy over here, it's got the little black case, which is also in your kit of parts. I actually drilled a hole through the top so I could see the LEDs. So you don't have to do that. So how do you know how to install that thing? Don't just try to willy-nilly plug it in. You're never going to guess at it right. So what you want to do is you want to go to the resources page on our website. And then you want to go to right here, the ESP01 installation. If you click on this, it'll bring up essentially a PDF of a Google Doc. And this will walk you through the installation. So it tells you about the pinouts, what the connections are. This has been actually tested by a couple of people, so the instructions should be fairly accurate. I'm not going to go over this. This takes a little bit of time to do, but it talks about how to plug in all this stuff with some instructions saying, please make sure your wires are correct, because if you power electronics on with certain wires in the wrong spot, you can burn them out. And then it talks about how to configure it so that it works on your Wi-Fi network, so you're not having to connect to the thing kind of directly and not be connected to the internet at the same time. So that's Terry wrote up those instructions. All right. And yes, this is mandatory for the challenge. This is how we're going to kind of regulate the game in terms of timing and so on. So you will definitely need to have this. All right. The next thing you'll want to do is make sure you have the latest firmware. So Terry's been busy updating these things. There was some instability that it didn't always program on the first try and so on, so that those are continuing to improve. There may still be some bugs because really this was all, everything we're doing is kind of, we're getting it done as we need it. So you guys are a bit of our beta testers too. So don't panic if things don't work perfectly. First, reread the instructions, make sure it's not you, and then go on Discord and ask for help. So people have already been doing that, and help has been being given. So again, the instructions, those instructions talk a little bit about updating the firmware, and you can also go to this page, a little bit in transition. We have this one page at elegoo.wwfirst.ca, which had all this information. We're actually in the process of porting it to the resource page, which is why most of it's duplicated here right now. One thing I'm not sure where we'll put is the latest firmware version currently sits on this page. It is 0.9.8. I don't know if we'll move that number to the resource page also. We'll have to see. Everything else has been copied over about an hour ago from Daniel over here. So. One important note, if not a lot of people have downloaded this version, and Terry can tell how many times a version has been downloaded, but if you have 0.9.5, like I did, and you can't upgrade, you go to the radio's webpage and you hit the upgrade firmware button, and it still stays at 0.9.5. Just go on Discord's Elegoo Kit help channel and ask for help there. Just say that you can't upgrade, and we'll help you out there. So. All right, number 4, we need what's called a certificate authority installed on your computer. And this has to do with a secure connection. And we made our own certificate so that the web apps that we're going to be using to talk to the robot have a way to kind of confirm that both ends are secure and the ones that are expected. So that has to be done to use those web apps. And there are some instructions on how to do it for Windows. And actually, check what else. I know there's Windows for sure, and Android. I don't think we have the iOS stuff there yet. Yes, we have Windows, Mac, and Android, which is, I believe, also the way you do your Chromebooks. It's very similar, if not. And we don't quite have iOS yet. All right, so any questions up to that? Those are all the prerequisites, so things you have to do. If you don't have those things done, you won't be able to get through the rest of these steps. All right, moving along. So what do you need to program the robot once you have all the hardware set up? Well, you need really 3 things. The first thing is a code editor, and that can be as simple as Notepad on a computer. It does not have to be anything fancy. You just need to be able to type text. Now, if you're doing block type programming or Scratch-like programming, then you'll need a tool that can do that for you. Arduino app is an IDE, which is an integrated development environment. I'll talk about that in a sec. The Arduino IDE is one that you can install on a non-Chromebook computer. ArduBlocks is an add-on. Tinkercad Circuits is its own thing that does blocks and code, or as I said, like you can use Notepad. So any of those tools, so either the kind of full-fledged packages or bare bones, will let you write code. Then you need a compiler, which is a tool that'll take your text or blocks, which are kind of like human-friendly, and convert them into microcontroller machine instructions or something similar. Okay, so the actual code the computer can read. And that's usually the same tool that you code with, unless you're using like Notepad or your favorite text editor. A programmer will take that compiled code and move it to your Elegoo. Your Elegoo is an embedded system, so it's a computer that is not on the computer where you write the code. And so you need a way to copy that code from the computer you write on to the computer that runs it, which is the Arduino on the Elegoo. And as I said, IDEs, they're this whole package that integrates the code editor, the compiler, the programmer, and often more things like a serial monitor, so you can monitor the messages coming back and forth from your robot. Sometimes they'll be able to graph stuff that comes out of the monitor and so on. So that's a IDE means integrated development environment, means everything together. I'd suggest you start with that because it tends to be easier. So let's look at the setup for any computer. So as I said or alluded to, a lot of students only have access to Chromebooks. Makes sense because WRDSB students get a Chromebook in grade 9. These have restricted permissions, so you can do some stuff to maybe do Arduino a little more natively on a Chromebook, but not with the restricted Chromebooks that most of you have. So they can't run most of these IDEs. So instead, a lot of work has been put in by mentors and possibly senior students to making a set of web-based tools that can do the job for us. So they can do the programming, so the coding, the compiling, and the programming all on a web app that any computer can run. So Waterloo Wellington First's version of Duino app. So Duino app is a public thing, but we have implemented kind of a subset of, or a server for it. So it's at duinoapp.wwfirst.ca. And that IDE will let you code in C++, compile, and program wirelessly. Chromebooks will not let you program wired through USB because you can't install drivers and so on. On the restricted ones, you definitely can on other ones. And you certainly can on Windows ones. And then the driver station, which is at elegoo.wwfirst.ca/ds, that allows you to operate the robot using an Xbox or Simmer controller. Okay, so you can actually drive this thing just like an FRC robot. All right, so let's look at how this works. And I'm actually going to jump out of the presentation and show you in the future if somebody does want to. You can read the instructions if you want to refer to the presentation, but for now, let's give you a live demo. Actually, I'll even click the link from here, make sure it works. There you go. So welcome to Duino.app. So the first thing you can do here, if you want, there's a little icon in the top right corner, which says install Duino app. If you click on that, it'll make an icon on your desktop and so on, and you're sort of running it offline. So you can do that. It makes things a little quicker to access rather than having to go to this address. You can also work fine by just always going back to this address. So the first thing you need to do is if you go to the bottom right down here, you click on server, make sure it's on this test compile server from www.first.ca. So that means that when you hit compile, it'll actually send your code to our server. Our server will compile it because your computer can't, and then it'll send the results back to your computer, which can be uploaded. So this one might have extra stuff to support the Elegoo. So if you pick some of the other ones, you may not be able to do everything you want to. So make sure you're on the WWFIRST one. Again, at the bottom, this says the board is Arduino Uno. That's the default and should be left that way. And then you've got select device port. So over here is where you would add your device's address. So by default, it's TCP to elegu.local. That's something that's called an MDNS name, multicast domain name service, I believe. And that is the default that this comes up. During your setup, if you haven't done this before, you will know what your address is. You may have noticed I also have an IP address here. That's what my router gave my robots as an IP address because I'm having problems with MDNS on my laptop. So I'm not always able to do it through MDNS, which is kind of a user-friendly name. So I might have to select this IP address. And the only way to select the IP address is either to go to your router and see who's there, or you can possibly do like a ping to this address and see to this name and see which address it is. If you get into that trouble, if you get into the MDNS conflicts, whatever, I don't want to cover that here. But again, go to the Elegoo help and we'll try our best to get you running. The good news is on Chromebooks, it worked the first time. So my son's Chromebook, which is WRDSB, sorry, Chromebook, and it worked no problem with this address. All right, so now we're set up. And in fact, if you hover over the second one here, if you get 4 green check marks so that the server is selected properly, the board is selected properly, you might not actually have a project selected at this point. So I'll go through that next. And the serial device is selected. So those are the 3 down here plus project. So when I go to code, the first time I go to code, it'll say you don't have a project, please create a new one. So it'll look something like this. Oh, sorry, that's a folder. That one there, project manager. it'll look like this, empty. You'll hit a plus, or there'll be a big button underneath, and you'll say, I want a new project. And we'll call this Eric's new project. Please don't call it Eric's new project. Okay, so this will be your test. And now if you click in, go into that. So that's, sorry, it is selected as current. Make sure it's current, whichever one you want. And then you go to code. It's kind of nice because it does give you a default chunk of code, which if you have attended, and actually I'll put a plug in for the programming sessions. If you are doing this in C++, we had 3 workshops on basic C++, so generic, just learning the language, learning the syntax. And then we also had 3 workshops on kind of C++ as it is implemented with Arduino. So you would have seen something very similar to this if you attended those ones. Now I'm just going to go quickly what it says. It says that I'm making this pin an output because it's actually built in LED, so I want to be able to turn it on and off. I want to open the serial port to be able to talk from the robot back to the console, so to the host computer. And then in a loop, I'm going to turn the light on, print out hi, meaning the signal is high, not really hi, how are you? I'm going to wait a second. I'm going to turn the LED off. I'm going to tell you that I turned it low, and then I'm going to wait another second, and then we just keep looping. So this thing will blink at 1 second on, 1 second off forever. So let us check. So first I'm going to switch my camera, if I can get to my settings. Yes, they're here. Let's go to here. And I want to show you that. So there's a red light on right now, but there's no blinking lights at all. So now what we're going to do, assuming this works, I'm going to hit the program, so compile and upload. If you just want to check your code, hit check and compile. That'll make sure that it's syntactically correct and all the bits and pieces you need are there, but it won't put it into your robots. That's a good first step. Or you can do this one, which does the same thing and it also puts it into the robot. Those inappropriate ioctl for device messages are normal. Those few there, that's okay. That one over there, so if you get attempt 1 of 10, odds are it's not going to program, and that's probably my computer having problems with MDNS. Sorry, anyway. The other thing you got to watch out for, don't do this. If you have, I did this on purpose just to show you guys. Yeah, if you're connected with the driver station, which we'll talk about later, you can't also connect with the IDE. So you have to pick one or the other. The connection is exclusive. You can't do both. All right, so let's go. I'm just going to pick the address because I know it works, although I think MDNS should work because I'm actually plugged in with Ethernet. Oh, that looked, I heard something happen there. I think it'll work. There we go. So now, if you can see, there's a green light flashing. So that's what this program does, is it blinks a green light. It does nothing else. Oh, that's not true. It does do one more thing. If you go to the monitor, so this is the program. If you go to the monitor, which is your serial monitor, this is where it tells you high, low, high, low. So there you go. So that's what this program does, blinks and talks to you. And this serial monitor is very useful for debugging your program, see what's going on. We'll talk a little bit about that later. All right, so let's go back to this, see what we got to or missed, and put the robot down, switch the camera over. All right. So we did this, we added the device, we selected the server, we went to the code tab, we created a new project, and we started our code. So there you go, that's a picture of what it looks like when it's empty. We could have checked and compiled our code using this, but given it was a stock program that I knew worked, we just went straight to the, upload also, so compile and upload. And some tips. All right, so the serial, we mentioned that, which is you can access it in the top right directly, or let me show you where. Make sure I'm not lying here. There, serial. It just brings up the window in monitor mode. So that's really useful to debug and interact with your code, as I mentioned. You can also add files by creating a new file and then pasting in the code. So if you have code from somewhere else you want to bring in, I found that if you create a new file, you can paste it in, or alternatively, you can actually zip up a bunch of files and import the entire project. See, I put a nice little note here. You can't connect Duino app and the driver station at the same time, so don't do that. It won't work. And this is a really important one. Once you start getting some mileage, you start writing a lot of code, please back up your projects. You're using a little web interface where you don't really know where the files are being saved. If you accidentally delete everything, if your computer crashes, you'll lose everything, and we really don't want you to have that experience. So please either control your code in something like GitHub, the source control tool, if you're used to doing that, or you can export a copy of the project every few hours of coding. Essentially, what are you willing to lose, and that's how often you should back up. And don't just back it up to your computer. Please put it to Google Drive or a separate USB drive or something, so you've got more than one copy on more than one device. And I'm just going to show you really quick on how that works. So in here, if we get out of the monitor, at the bottom here, you can export your project, or you can import it also. Okay, so exports or imports. All right, so next is the driver station. The driver station, you saw a little bit of, earlier, but it's a way to send commands to your robot via a controller. It can also run you through the match timing, so it'll let you run through the autonomous period, the teleop period, or run a full game, which is 15 seconds of autonomous plus the 75 seconds of teleop. At this point, you will need a controller in order to be able to do this. And you can use a couple of different controllers. You can use an Xbox controller. You can use a Logitech controller like this. This is the F710. The F310 looks like this, but is a dark blue and is corded. The cord is not a bad thing for this because you don't have to worry about interference or anything like that. And also the corded one is $25 right now at Best Buy, Canada Computers, and Walmart. So it's a fairly affordable one. This one's about twice the price, about $50. And the only thing you get is wireless, and pull the batteries out if you're not using it, because I find it chews through them if you leave it for a couple of weeks. So yeah, you may have seen these with FRC. I know 4917 drives with F310 Logitech controllers. And we go through a couple every year too, because they do wear out a little bit, but I don't foresee us carrying as much in this in terms of precision. All right, so how does the driver station work? Well, you go to elegoo.wwfirst.ca/ds. For the host name, if you haven't changed the default, it'll likely be tcp2 elegoo.local, just like we had for Duino app. The controller does populate itself if there's only one, or you can hit the drop down if there's multiple you need to choose from. The really important thing to do is, and it does tell you this, I actually missed it the first time. Once it's plugged in, you have to tap a button in order for the app to know which controller you're using and to confirm that one is actually working. And I'll show you that in a sec. So you press a button on the controller, then you hit the connect button, which when you're not connected says connect. When you are connected, it says disconnect. I know, shocking. So this just connects you to it, and it'll also show you the console output. So just like the serial monitor from the Duino app, you can see messages right from the driver station. So you pick your match type, and then you hit start. You can also stop to come back to the kind of idle state, but make sure to disconnect when you're done, or else you'll do like me and not be able to program it anymore. So I've got a flashing something. Chat. Will a PS4 controller work? That is a good question. Hey, I've had a few questions. Thanks, Terry, for monitoring that. I didn't have my chat window open. It can work. You may need to have I probably have it on here. There's an app that translates PS4 controllers to Xbox type controllers. So if you use that app on a PC that works. We do that. We did do that as a family. So to play Steam games, whatever, we will pair. I think if you hit like share in the PlayStation button, you can Bluetooth pair a PS4 controller or PS3 controller to a PC, and then you use that. It's called like PS4 to Xbox or something. I forget exactly what it's called. You have to Google it, and it'll translate the PS4 commands into normal controller commands that it understands. I'm pretty sure you can do it with that. I don't know if that would work with your Chromebook to be able to pair that. You'd have to try it if that's what you're using. The Logitech wireless that I have has a little USB dongle, so you don't even have to pair it with Bluetooth. It's actually probably 2.4 gigahertz or something, but it's going through your USB. All right, so let's look at what this is. I will click on here. And so it says right now, click on Xbox controller. So it means it's found one. So I'm just gonna take this and I'm gonna click one of these buttons, and that just switched to Xbox 360 controller, X input standard game. The reason it says X input is these controllers have a X and a D switch on them, or on the bottom for some of them. I have not so far seen the difference. It has something to do with these ones being either buttons or throttles and a few other things. So you may need to experiment with that, but it does work with both of them, at least for the joysticks, because I've driven with both. So for this match type, we're gonna connect first, sorry. We'll see if my MDNS works. The other thing I'm not super clear on is what happens with this being on. Will that be a problem? Which it might be. We may actually have to close this tab. I'm just gonna close that, reload that, click a button on the controller, hit connect. There we go, that worked. Yeah, so your Arduino app was connected because of its serial monitor. All right, so now if I move the joystick, nothing happens because it's not connected. It's not started. So this is kind of like you're connected to your robot, like FRC, but you're not enabled if you're familiar with FRC. What I'm going to do is switch cameras. All right, so so I'm going to grab this over here and I'm going to go to start. Oh, I forgot to step here. I'm going high-low again. So I'm going to show you it doesn't work at all. Nothing happens, and that's because there is no code on my robot to support this. So I'm going to go back to the Arduino app. That driver station right there. I'm going to go back to code. I have a project loaded. Actually, I'll show you also in here. So right here at the bottom of the resources page, in this section of right there, Elegoo competition software and instructions. If you scroll to the bottom of that, it says in order to be able to use a controller to drive your robot, you need to access the driverstation.h file. And we have a sample that includes driver station that we can download here. So I'm going to click that. It's going to download Elegoo demo.zip. I'm going to go to Arduino app. It actually wants zip files, so that's kind of convenient. I'm going to import a project. I'm going to call it Elegoo demo workshop. I think I already have one called Elegoo demo. And I'm going to click this, and I'm going to grab the Elegoo demo, and I'm going to create that project. So now I have this code. We're not going to go through it in detail here, but essentially it implements all that we need for playing the game. So it includes the car information. So that's in this header file, has all the code to be able to talk to the motors and so on. We have a servo because there's a bit of a servo demo, and the driver station. So this is in order to kind of get the information from the joystick from the driver station on the PC, it gets sent automatically by the driver station to the ESP01 radio that sends it to the Arduino, and then the Arduino can access those values, the joystick and button values, by using the data that's coded in driverstation.h. So we just need to declare a driver station, and then we can access those things. So for example, if we just go down, so in Teleop, we can get the right y-axis or the right stick's x-axis from the driver station and get that as a value. I won't go through all the details, so it's pretty well commented in here. Terry did a nice job there. But you need to get that information in order to actually execute something. It does not happen magically. You're the one that decides. If you wanted the red button to be forward, you could code it so that that red button goes 50% forward, whatever you want. So that's up to you. But as a test, to make sure everything's working, we will make sure everything's closed. I'm pretty sure this one will work now. Now green check marks, let's program. Oh, there's a warning here of an unused variable. I should have removed that. I didn't realize, but don't worry about it. It's just, you can delete it if you'd like, or just ignore the warning. It really is a variable that's not used. Oh yeah, Terry had a good point. When you're programming your radio, make sure that your SSID is all the right case, because that'll certainly cause it not to work. That's your network ID. Yeah, and I do have, I did keep the little Elegoo box here again as a reminder, don't throw it away. That is your platform for your game. So, all right, 100% done. Cool, so I'll close that, go back to the driver's station. You can bookmark these things. I will tap a button on here. I will connect. Let's get rid of this. You even get a nice little beep countdown there. There we go. So now you can even see the messages coming out of the console output. If you're getting start game, pre-game, tele-op, that means that the code is running. So now if we go and look at the camera, I realize this will be a little small. I'll go forward. Eventually the robot will come into view. Oop, unless I drive it there. There we go. So forward, backwards, left, right. And if you look really carefully, this stick makes the ultrasonic sensor go to where you're pointing the stick. So let's see if we can get a little closer. Nope, not if I close the hood in my camera though. There we go. So there you go. So I'm going left a little bit and it's proportional. You could have it as a button too, but it's all on joysticks right now. Stay there. All right. Any questions? Okay, good. So Terry did confirm that if you go to the, I had shown you that for the other one for Arduino app, but if you install the driver station by clicking that here, you can actually run it without going online. There's kind of little point to not being online with the Arduino app because you can't compile locally. You're sending it to the server to compile, but the driver station running offline makes sense because you don't need the internet to drive your robot. So I will disconnect from here. There we go. If you click autonomous, you'll get a little countdown, then it'll start the autonomous routine, and there's an example of that in the code, and that's the function that executes during autonomous, and then it'll automatically start running your teleop code, excuse me, in once you get the autonomous done. So it works like a real FRC game. And your joystick commands should not do anything in autonomous. They should only be enabled in teleop. So. All right, so let's go back to that. All right, so just before I jump to the next one, does that make sense? So just as a quick recap of what we're doing. So first, let's switch the camera. Okay, so number one, I'll just go there, that's fine. Number one, we want to do the assembly of the hardware, and you need to have the wireless radio. Number two, you need to have all your firmware updated and that kind of stuff. And then you're looking at getting an IDE where you can type up your code. You need driverstation.h, so you get it from that example file. You can write from scratch, either starting from that example file or just put that driver.h alongside your Arduino code, any other one. Yes, I can go to the admin page. And then after you've coded it, you program it. And after you think it's going to work, then you try driver station in order to have control of your car. So if I go to TCP2 elegoo.local. Oops. Yeah, Google will Google that for you if you don't put an HTTP in front of it. So http:// there you go. The default username is admin1234. His default password. I'm not going to save that. So here is where you can update the firmware. You just click that. It'll automatically query the server for new firmware, and then it'll tell you, give you like a 2-minute countdown to reload. It does show you your IP address. If you can get to it from here, then you can use your IP address, which is really nice. Server status, this is the certificate stuff, so that's running. If you want to put a password, a new password, you can. If you want to change the name, you can. This is where you put your network ID. So our network is GNet. And it is important to do the capitalization correctly. The network key is your password for your Wi-Fi. Do not change this number. This is what it needs to be. And then you hit submit. So that's how you manipulate that. Any other questions or things in the chat that I should elaborate on? I haven't been paying attention to it. Awesome. Yeah, anything else, just let me know. If you raise your hand, it's easier for me to stop and see than the chat, but obviously we have people monitoring the chat too, so that's awesome. That's a downside. Usually I'm the one managing the call and not presenting, so it's hard to do both. All right, so alternative setups you may like. So you may know Arduino and you're like, Eric, I don't like Arduino app. I've got this other thing that'll do syntax highlighting and it does this and I love it. Like, great, that is not a problem. If you know how to do something else, if you prefer to do something else, or if your buddies have told you you should use something else, that is okay. You can definitely use the traditional tools. So for example, Arduino IDE, which is a desktop app, and I have it on here, so let me give you a quick look. So just this little guy here, you can obviously make him bigger, but he always comes up really small. So again, it gives you the skeleton of the code. You can go and add in add-ons and so on to help, like libraries you can add for hardware. There's a ton of stuff you can do here. If you're doing it, if you want to use it wirelessly, so wired, you would just pick a port and it would be like COM1, COM2, whatever. If you're doing it wirelessly, you'll have to go again to, I think I do say that right here. You'll have to go to our website, download a package, which will make this thing appear, the Elegoo V3 Plus AVR. So you'll select that instead of the Arduino for the board. And you're going to select your IP address or your name as the port. And that'll let you program wirelessly. So normally this works with USB that you would hook in, but people have worked and made it possible to do it wirelessly. And that brings me to my next note here. Whoops, sorry. If you do program via USB cable, you have to unplug the ESP01 because they share some lines and they'll fight and you don't want electronics to fight. So unplug the wireless module in order to program using USB. So this ID is available at this address, and the Wi-Fi package I talked about is available on, the instructions are available on the resource page. And if any of these links change in the future, we'll try to put a note somewhere. We just changed them, as I said, like a couple of hours ago. So ardublocks, if you're not a C++ programmer, like I really want to program with ardublocks, well, the cybercavs have written a bunch of tutorials, and I think that's what they use. So there will be videos that are coming out at a later date that allow you to program with blocks, so kind of Scratch-like. And ardublocks is an add-on to the Arduino IDE. So you can't use this with just a Chromebook because you can't install Ardublock. But if you have another type of computer, you can add that. Tinkercad circuits, if you really don't like writing code in any of these things, or you want to do some Scratch type block programming online, Tinkercad circuits will let you do that. So you can learn their block language, and then you can go to the code section. So you go from blocks to code, and then it'll give you the Arduino code in C++. You can just copy, put in Arduino app, program that way. So if you really want to use blocks and you're on a Chromebook, go to Tinkercad, go to their circuits section, and start investigating their blocks. We do not have tutorials for their blocks, and they are different, so keep that in mind. All right, so we're going on 40 minutes here, sorry. taking a little longer with those demos than I expected. So you've got the driver station working because you use that demo code. You know where to write code. You know how to program it in there. So what's next? Well, if I were you, I would start trying to write code to interact with the different pieces of hardware. Okay, so there's servos you can play with, ultrasonic sensors and DC motors built right in, and then there's a bunch of other stuff that we gave you in your kit that you could also add on. Do take it one piece at a time. Don't try to write a robot that looks where it's going, turns, and all that stuff. Don't write your whole auto routine before testing it. Take it one piece at a time. Make sure you know how to make the robot go forward. Then make sure you can turn your servo if you need one, and make sure you can read the distance on your ultrasonic sensor. Do that one at a time. Don't try to do everything at once. I've said it before, I'll say it again, the serial monitor is your friend. Use it to print out messages to tell you where you are in the code. Sometimes you have an if statement, you think you're going in, and you're not. So put a message in there that says, I'm in here. And you can pepper your code with I'm in here X, I'm in here Y, or even just I'm in here 1, 2, 3, 4. And make sure your code is doing what you think it's doing. And you can also print out the distances from the ultrasonic sensor or the power you're giving to your motors based on your joysticks. So do all that. And finally, what if you want more information? Well, I found the Elegoo's tutorial information is quite good. And very importantly, it has the schematics for the kit. So the schematics is the map of where all the pins go. And the Elegoo uses almost every pin on the Arduino, which is why we have an expansion board in your kit. But if you'll have a very hard time putting everything in your kit on your robot. If you want to do line following and you want to use 2 ultrasonic sensors and 3 servos, you're going to run out of pins. So you're going to have to make some sacrifices. So to know what's available, look at the schematics and read the data sheets. Data sheets are kind of the manual for the electronics. So what can they do? What do they need to work? For example, servos need to go on a PWM output. They can't be put on any pin. That's important. There's also lessons and sample code for the robot. There are like 7 or 10 lessons you can go through. There's even a little function demo video, which I recommend you watch at least like the first 30 seconds or a minute, which shows you what the robot can do in case you don't know. And then download the actual, there's a kit, a zip file. So all those are available at this address. Get the zip file, open it up, look through it, take your time, figure it out. I've already done a plug for our workshops. This is the channel. And now I'm going to do a plug for the channel. If we have 100 subscribers, we can get rid of this thing for a name and actually put like channel/WWFIRST and some other things. So we were at 66 subscribers when I checked. If you don't mind subscribing, you don't have to subscribe to notifications. Don't need to do the bell. But if you subscribe, we'll be able to do more stuff when we hit 100. And then as always, Google and YouTube are your friend, and of course, Discord. So I'm going to leave it at that for my talking since I've gone on. So now's a great time for questions. If you have questions, you want to know how to do something, you want me to show you something, go ahead, we can do it now.